Hello friends, good evening. I am Dr. Kaustubh and I welcome you to UPSC Guides Prelims PYQ discussion series. In this series, I'll be discussing the PYQs of geography to identify the key concepts, the patterns, and whatever the concepts are, along with the takeaways for solving prelims PYQs. This will help you refine your strategy and improve your accuracy in this most important qualifying examination. So let us start our discussion. Before we begin, let us look at the pattern or trends कि यूपीएससी में ज्योग्राफी प्रीलिम्स में ज्योग्राफी के कौन से सवाल कितने सवाल आते हैं. सो इफ यू लुक एट दिस ग्राफ, दिस इज 2013 to 2024. You will see that 2013 the number of questions was nearly 20. Then 18, 17 फिर बहुत कम हो गए, 7, 8, 10, 5, and then you will see that now again it is rising. What is the takeaway? The takeaway is do not fall for this pattern. The point is it is unpredictable. Every year, how many questions from a particular topic will appear in prelims? This is highly unpredictable. If you see, there is no consistency in UPSC's choice of questions from a particular topic. So, इससे ज़्यादा important ये है कि आप prepare अच्छे से कर लो, तो कितने भी सवाल पूछ ले तो you will be confident enough to answer them, right? Next, distribution of questions, world and Indian geography, topic wise अगर हम देखें, so solar system, geomorphology, climatology, oceanography, you will see climate पे there have been a lot of questions. World mapping, again a number of questions, 22. Then we have river systems. Here is Indian map locations or economic geography. So again I would say overall there is no topic that can be completely neglected, or it is not like this that there is a particular topic and you have to focus on that topic only. Rather मैं आपसे कहूंगा कि एक कॉम्प्रिहेंसिव प्रिपरेशन अगर आप करते हैं तो आपके लिए अच्छा है, क्योंकि प्रीलिम्स जैसी कट थ्रोट कॉम्पिटिशन में एक एक मार्क, एक एक सवाल, एक एक नंबर सिलेक्शन और रिजेक्शन का कारण बन जाता है. सो ऐसे इसमें इट इज नॉट वेरी इंटेलिजेंट कि आप कोई टॉपिक छोड़ दे. इट इज इंपॉर्टेंट टू कवर एवरीथिंग प्रॉपरली एंड आंसर द क्वेश्चंस which can be answered with minimum effort, right? So with this understanding, let us start our discussion from questions from the topic solar system. तो अब हम शुरू करते हैं solar system इस टॉपिक से. The first question here, variations in the length of daytime and nighttime from season to season are due to, this is 2013 paper. Variations in the length of daytime and nighttime from season to season are due to, the four options are Earth's rotation on its axis, the Earth's revolution around the sun in an elliptical manner, जो orbit है, third latitudinal position of the place, so जो भी location हम Earth पे देख रहे हैं उसका latitudinal location कहाँ है towards northern hemisphere और southern hemisphere, and then due to revolution of the Earth on a tilted axis. Now the answer is D. Why? See, look at the question. The question is asking variations in the length of daytime and nighttime from season to season. तो seasons किस वजह से आते हैं? If you look at geography, basic concept, the reason for seasons, right, is revolution of the earth around the sun, right? But the variation that comes is this revolution plus the tilted axis. So the revolution of the earth on a tilted axis around the sun. So tilt is constant, 23.5 degree, right? So this tilt is constant. So this tilted earth revolves around the sun, and this results into seasons and the variation of day and night in northern and southern hemisphere, right? So answer is D, due to the revolution of earth on a tilted axis. Now if you look at axial tilt, right? Axial tilt, it is constant. Second, this tilt causes different parts of the earth to receive varying amounts of sunlight because the the axis is tilted, right? Some areas would receive perpendicular sun rays, some of them will receive slanting sun rays, and this will cause variation in the heat received as well as the duration of day and night. So as the earth revolves around the earth, different hemispheres experience longer or shorter daylight hours. This results in seasons. So seasons भी है और ड्यूरेशन ऑफ डे एंड नाइट भी कम ज्यादा है. सो व्हाई आर द अदर ऑप्शंस इनकरेक्ट? Earth's rotation on an axis. See, all of you are aware Earth's rotation on its axis, it causes day and night. That doesn't result into seasons, right? Second, the Earth's revolution around the sun in an elliptical manner. Now, see, जो plane है, जो orbit है, Earth revolves in an elliptical orbit around the sun. That may result into that revolution on a tilted axis, right? In an elliptical manner. This is slightly elliptical, but this is negligible impact. ये जो ellipse है, it has negligible impact on the day and night का duration. The major impact is revolution plus the tilt, right? So the primary cause is the tilt of Earth's axis, right? Not the elliptical shape. Next option is latitudinal position of the place. Now, latitudinal position of the place, this determines the amount of daylight a place receives, right? The seasonal variation is due to Earth's tilt and revolution. So seasonal variation is because of revolution and tilt. ये जो चीज है latitudinal position, it will only determine the amount of heat, the amount of sunlight that is received at a particular place. Clear? So final answer is D, due to revolution of the Earth on a tilted axis. I hope this is clear. Let us go to the next question. The term Goldilocks zone is often seen in news in the context of, this is from 2015. Now, when you talk about Goldilocks zone, the meaning is, if you take any star, if you take any, for example, sun, हमारा sun है. So from our sun, if you calculate the distance to identify a zone in which life is possible. So you take a star, and in this star, you identify a distance from the star where you get the probability of finding life is high, hospitable zone hai. So that is called the Goldilocks zone. Now, what was the context? The context was the researchers on the Earth were trying to find extraterrestrial life. Apart from our solar system, we are trying to find life elsewhere in our universe. So how do we look for it? We look for life in the zone away from a particular star where the temperature would be conducive enough that the probability of finding life would be more, right? So that is the important, that is the answer to this question. The limits of habitable zone above the surface of the Earth? No. Goldilocks zone is not calculated from the Earth. It is calculated from a star. आप जानते हैं, there is a difference between star and planet, right? Planet only reflects the light from the star. Star has its own light, जैसे हमारा sun है. तो distance from the star is important to calculate this habitable zone, not from the planet or Earth. Regions inside the Earth where shale gas is available, absolutely wrong answer. This term Goldilocks zone has nothing to do with shale gas. Search for the Earth-like planets in outer space. Yes, this is the answer. Search for meteorites containing precious metals. Again, Goldilocks zone is not associated with meteorites containing precious metals, right? So answer is C, search for Earth-like planets in outer space. Explanation is given here. Goldilocks का मतलब ये होता है, it is a habitable zone around a star, right? Around a star where conditions are just right. So the temperature is not too hot, not too cold for liquid water to exist. And we know this, that when water is in the liquid format, the probability of life originating or sustaining itself there is very high. Exists on a planet's surface, making it potentially suitable for life. This is widely used in astronomy to identify the exoplanets, which have Earth-like conditions to support life, right? We have seen why the other options are wrong. Pehla wala, the limits of habitable zone above the surface. No, it is from the star. We have discussed that. It is not from planet like Earth. Second, shale gas. No, the term Goldilocks has nothing to do with shale gas. And next, meteorites containing precious metals. Again, meteorites can be anywhere and they may have precious metals, but their existence has nothing to do with the existence of Goldilocks zone. So Goldilocks का और इस mineral rich meteorites का कोई relation नहीं है. That is why the final answer which is correct is C, search for Earth-like planets in outer space. I hope you have understood this. Let us go to the next question, but before that, UPSC Guide is launching a prelims 2025 test series which is called PARIKSHA. The details about which are given in the description box and will be communicated to you. So please follow and join this test series for better accuracy in your preparation. Next, on 21st June, the sun. Now there are 4 options. Question सिर्फ क्या कह रहा है? 21st June, right? The sun, and then 4 options are given. Now before we go to the options, you know that 21st June, which we celebrate not only in India but throughout the world as International Yoga Day, right? योग दिवस करके इसको हमने डिक्लेयर किया है. So this 21st June is significant. Why? Because we know that the rays of the sun are perpendicular overhead over the Tropic of Cancer in northern hemisphere. On 21st June, the rays of the sun are overhead or perpendicular at Tropic of Cancer in the northern hemisphere, right? So on 21st June, the sun does not set below the horizon at the Arctic Circle, which is absolutely correct. Why? Because on 21st June, which is known as the summer solstice in northern hemisphere, on summer solstice, the sun does not set below the horizon at Arctic Circle, North Pole, because on 21st June, the tilt of the northern hemisphere, the axial tilt of the earth, the tilt of the northern hemisphere is towards the sun. So I'm going to show you by drawing a diagram. Yeah. So if you take this as the sun and these 4 positions of earth, and this is the axial tilt, which is constant, right? So this is 21st June. You know, this is 22nd December. This is around 23rd September, equinox, and this is 23rd March, again an equinox. So this 21st June, the northern hemisphere is tilted towards the sun, right? The rays of the sun are overhead, perpendicular over the Tropic of Cancer, and this results into longest day in the northern hemisphere. So at Arctic Circle, which is completely tilted towards the sun does not set below the horizon. That is why it is the correct answer, right? So does not set below horizon at the Arctic Circle. Look at the other options. On 21st June, the sun does not set below the horizon at Antarctic Circle. No. In Antarctica, there is a long, wintry, cold night. Sun does not rise. So if the sun does not rise, there's no question about sun not setting below the horizon. So when there is sun is overhead in the northern hemisphere, summer solstice, June, Antarctica does not have sun over the horizon. There is a long continuous night for months altogether, right? Shines vertically overhead at noon on the equator. No, you know, when the sun is overhead at equator, it is called equinox. The dates are March and September. So 22 to 23rd March and 23rd September. These are the equinoxes, right? When the sun is exactly overhead the equator. So this is not in June or December. June or December are solstices. 21st June being the summer solstice, and 22nd December being the winter solstice. Shines vertically overhead at the Tropic of Capricorn. Again, this is 22nd December when the sun is exactly overhead Tropic of Capricorn, right? In the southern hemisphere. So the answer here is A. Does not set below horizon at the Arctic Circle. So I have already told you that when you talk about 21st June, it is the summer solstice. The axial tilt is towards the sun, northern axial tilt. So North Pole is tilted towards sun. Sun remains above the horizon for 24 hours at Arctic. Tropic of Cancer receives direct 90 degrees, right? Sunlight. Other options are wrong because Antarctica, it is 21st December, 22nd December, shines vertically overhead at noon on equator, that is equinox. right, which we are not speaking about, and shines vertically overhead at Tropic of Capricorn. This is also wrong, which is in December actually, not the 21st June, right? So a final answer is A, does not set below the horizon at Arctic Circle. Clear? Next. Which one of the following is the reason why astronomical distances are measured in light years? So why are astronomical distances measured in light years? You could have other options like sound, right? But then sound doesn't travel in space, we know that. So light travels in space. So why is it light year is as a unit is used to calculate the distances in astronomical or space, astronomy or space? Distances among stellar bodies do not change. Now this is simply wrong. See, apply simple common sense. Distances between astronomical bodies do change. You know that the universe is expanding, right? And astronomical bodies, including say comets, stars, planets, they are in motion. So the distances between these bodies would change. So first option is wrong. Gravity of stellar bodies does not change. Again, here, over a period of time, yes, the gravity remains constant more or less, but what has that to do with light year? Light always travels in straight line. Now this is a bit puzzling. It seems appealing, but this is again wrong. Why it is incorrect? We know that light travels in a straight line. That's fine. But we also know that Einstein and his theory of relativity tell us about bending of light in the universe. So light, especially around black holes, there are zones where the light tends to bend, right? So this is not factually completely accurate or correct. So speed of light is always same. This is more correct or accurate answer, that the distance in space are measured in light years because the speed of light is more or less constant, right? Now that is the answer. Explanation: a light year is a distance that light travels in 1 year, which is approximately this much, which is given in numbers in front of you. The reason astronomers use light years to measure is light travels at a constant speed, around 3 lakh kilometers per second, right? In vacuum. And in space there is vacuum, right? There's no media, there is dark matter, but we are yet to study dark matter in detail. Since the speed of light is always same, it's a reliable and consistent unit to measure distances. Now, other options are incorrect because distance among stellar bodies do not change. I've already said that distances do change, right? Gravity of stellar bodies does not change. Again, gravity also is a function of mass and distance, right? And then light always travels in straight line. Einstein's general theory of relativity, it is bent by strong gravitational fields. It is called gravitational lensing. That is a term which you should remember for your prelims. Gravitational lensing, the bending of light, right, by strong gravitational fields. For example, around a black hole. So hence, this is not the reason. Final answer is D, speed of light is always same. That is why light is used as a very reliable, consistent unit to measure distances between the astronomical bodies in space, right? Next, in the northern hemisphere, the longest day of the year normally occurs in northern hemisphere, and they are asking longest day of the year, right? In the northern hemisphere, the longest day of the year normally occurs in. Now again, which day it should be? Abhi हमने discuss किया 21st June, summer solstice, the rays of the sun completely perpendicular over Tropic of Cancer. We also saw that on that day, the sun simply doesn't set below the horizon in Arctic Circle or beyond the Arctic Circle. So first half of the month of June, no, because 21st June is the second half of the month of June. Second half of the month of June. Yes, that is the answer, that in the northern hemisphere, longest day of the year would fall in second half of the month of June. First half of month of July and second half of month of July, this is wrong. If you know the date well, summer solstice, 21st June, this is given in your NCERT also, right? So answer is second half of the month of June. Explanation, again, the same one, that longest day rays perpendicular, sun is exactly overhead, Tropic of Cancer in the northern hemisphere. It is the result of the axial tilt of Earth, the North Pole, towards the sun. Sun is directly overhead, Tropic of Cancer. At noon, second half of the June, so option is this. Other first half is before 15th, which is wrong. First half of month of July or second half of month of July, again it is wrong answer because the date is specific, 21st June, the International Yoga Day. Next, consider the following pairs of objects in space and its description. Cepheids, giant clouds of dust and gas in space. Nebulae, stars which brighten and dim periodically. Pulsars, neutron stars that are formed when massive stars run out of fuel and collapse. How many of the above pairs are correctly matched? Only one, only two, all three, or none, right? So here, only one is the answer. Let us see why. Cepheids, giant clouds of dust and gas. This is wrong. Why? Because, this definition, giant cloud of dust and gas, it is the description of nebulae, right? A nebula is a giant cloud of dust and gas. You know how our solar system was formed? When the universe was expanding after the Big Bang, these giant clouds of dust and gas were caught by the gravity of sun, proto-sun, and then this cloud started revolving around or rotating around, revolving around the protostar, giant star, and so slowly and steadily our solar system came into being. So ये जो giant cloud of dust and gas है, इसको nebula कहते हैं, उसको Cepheids नहीं बोलते. So giant cloud of dust and gas, it is incorrect, right? Cepheids are a type of variable star, not cloud of dust and gas, right? Correct description, stars which brighten and dim periodically. That is Cepheid. Again, nebulae, stars which brighten and dim periodically. No, that is the definition of Cepheid. उन्होंने वो interchange किया है. The question is framed by interchanging the definitions of Cepheids and nebula. So nebula are giant clouds of dust and gas in space, not the stars, right? Nebula are believed to be the birthplaces of stars. Right? Correct description is giant cloud of dust and gas in space. So incorrectly matched. Pulsar, yes, this is the correct definition matched with concept. Pulsar is neutron stars that are formed when massive stars run out of fuel and they collapse. Isko pulsar bolte hai, right? So only one pair out of these three is correctly matched. That is why the answer given is A, only one, right? Next. Consider the following statements. Statement 1, giant stars live much longer than dwarf stars, right? That is first statement. What is the second statement? Compared to dwarf stars, giant stars have a greater rate of nuclear reactions. So it is said that, the two statements seem to contradict each other, but the first statement says giant stars live much longer than dwarf stars. And compared to second statement is compared to dwarf stars, giant stars have a greater rate of nuclear reaction, right? Now, which of the following is correct in respect of above statements? A, both the statements are correct, and statement 2, statement 1 and statement 1. So it is like, both statements are correct, and the second statement explains the first statement. Second, both statements are correct, but statement 2 does not explain the first statement. So both are factually correct, but they are not, the statement 2 doesn't explain the statement 1. C, 1 is correct, 2 is wrong, and D, 1 is wrong, 2 is correct, right? 1 is wrong, but 2 is correct. So answer is D, statement 1 is wrong or incorrect, and statement 2 is correct. Why? See, what is statement 1? Giant stars live much longer than dwarf stars. ये गलत है. See, this is true. जो statement 2 है, that giant stars have greater rate of nuclear reaction, right? But then, if the rate of nuclear reactions is high, it may not sustain for a very long period of time. Correct? So, giant stars live much longer than dwarf stars? No, this is wrong. That is why statement 1 is incorrect. Dwarf stars, especially red dwarfs, have much longer lifespan. So dwarf जो होता है ना, dwarf live for a very long period of time, right? Dwarfs live for a very long period of time, especially the red dwarfs. Giant stars burn fuel at an extremely high rate. That is why they cannot be living for a very long period of time. Dwarfs they burn fuel very slowly, right? They live for billions of years, right? Statement 2 is correct. Compared to dwarfs, giant stars have a greater rate of nuclear exchange. They burn the nuclear fuel very fast. Clear? So statement 2 is correct. Statement 1 is incorrect.